Hello everybody, this is the Adafruit CircuitPython Weekly for June 25th, 2018. This is a weekly meeting we have between the folks that are sponsored by Adafruit to work on CircuitPython and the community members who also do lots of really awesome work. It's a chance for us to sync on both what technical work we're doing, but also what projects we're working on and how those are going. Everybody is welcome to join the meeting. The meeting happens at Mondays at 11 a.m. Pacific, 2 p.m. Eastern on our Discord channel. To join the Discord channel, you can go to adafru.it/discord. That will drop you into our Discord, and even if it's not during the meeting, a bunch of us are usually in the text channel for CircuitPython, so say hello there. This meeting is structured into 4 parts. We start with a state of CircuitPython, which is statistics that I pull every week about how the project overall is going. And then we'll follow that up with hug reports, which is a chance for everybody to say thank you to other folks in the community for the work they've done. We do it in a round robin style, so I'll start and then go down the list of people in the voice chat. After hug reports, we'll do status updates, which is a chance to talk about what you've done in the last week and kind of what you plan on doing in the next week. It's a good chance to get pointers and tips and tricks and stuff from other people, and also make sure that everybody's aware of what's going on. There was something else. These meetings are recorded. They're available on youtube.com/Adafruit. There's a playlist there that you can listen to the back catalog of meetings if you so desire. Or if you just missed a meeting, that's where you can find it as well. It's also pinned in the Discord text channel there. And as the meeting goes along, I take notes, so you'll hear me typing on my keyboard and maybe pausing the meeting while I catch up. That's because I'm putting notes and time codes in the that will go with the video recording that you can see later. So if you don't want to listen to the whole typically hour-long meeting, you can check out the notes and then skip to the parts that look most interesting to you. So I'll take a time code and get us going here. First section is the state of CircuitPython. This is both the core code and the libraries and the newsletter and basically everything related to CircuitPython on GitHub. In the last week, we had 17 pull requests merged from 10 different authors. Shout out to GG Techie in particular as a first-time committer, I believe. We had 5 reviewers for those 17 pull requests merged, so that's good to see more people reviewing as well. We can't have more pull requests merged without having more people to review them, so thank you, reviewers. Issues-wise, and we have 12 open pull requests, so if you haven't done a review before and want to, check out the notes for links to all of the open pull requests that could use some eyeballs on it. These notes are a little old. I did a couple of reviews after I took them, so beware of that. That's a good problem to have. Issue-wise, we had 9 closed issues by 3 people and 10 opened by 8 people, so we're net gain of 1 issue. Not too bad. Kind of expecting actually to kind of blossom issue-wise for the core CircuitPython repo as we go into the 4.0 development cycle. And we have 133 total open issues. A number of those are on driver repos, so if you have some spare time, take a look at this list. There's some stuff we could knock off there, I'm sure. Download stats, we had the first release candidate of 3.0, I believe last week, and it's had 260 total downloads, which is really good and getting people experimenting with it. There was one showstopper with the ESP8266, I believe, so this will not be the final release for 3.0, but we'll get there pretty shortly. There's not too much changing, which is good. The stable release has 2.31 and it's 3,200 total downloads at this point. I forgot to take the diff from last week. Overall, we're in this really fun period right now. At least I find it fun, where 3.0 is basically done. There's a couple issues that we're hunting down, and Dan's been doing a good job of that. but then we'll get that out of stable, and we'll start migrating people away from the 2.0 or 2x series that went really well and carried us this far. But now we're in the early stages of 4.0, so we can do a lot of experimentation on master, try out different things, and figure out what exactly 4.0 will be, which is very exciting. Okay, so that's a couple words about where I think CircuitPython is and the state of CircuitPython. Let's move on to Hug Reports. Hug Reports is a section where you get it. We give everybody a few minutes to say thank you to those that have been doing some awesome work within the community. And so I'll go in a round robin unless you're lurking, and just give everybody a chance to say a few quick thank yous. And I will take notes during that as well. And I'll start with myself. So I have two this week, well, 2 bullet points. First, thank you to TG Techie for the first PR. I don't actually remember what it was, but it was really cool to see TG Techie growing into somebody who's a contributor. Been doing a lot of hardware design with an M4, which has been cool. And then I also wanted to thank Summersoft for helping with some Git issues for TG Techie as well. And then second, I wanted to shout out to Aaron Averill on the forums for the NeoPixel Animation Helper Lab. Looks very cool, and I'm hoping that we can get that into the community bundle. So that would be really neat as well. Okay, Andon, do you have any Hug Reports? And some people will be only text only, so I'll read those off. For those of you who are not watching the video stream. The video stream is in the recording if you do want to see what Discord looks like and things like that. And it says Andon's typing, so that's why I'm waiting. Hug report, everyone as always. Now that things are moved around, I should be able to peek at actual specifics more often. Awesome. Oops. I was working ahead and already took time codes for people. Carter.
Basic group hug, as always.
Okay.
And then to you, Scott, for reviewing and merging those PRs for the HT16K33 stuff.
Awesome.
And keeping up the chat with the issues and whatnot.
Yeah. Issues are good. All right. Dan, go ahead.
Okay. Thanks to Jerry again for testing the ESP8266 and finding out things wrong with it. So I fixed some things there, and also you noticed some missing pins on the ITC-M4. And also thanks to Lady Ada for spending a lot of time getting started on the NRF port and sort of laying a foundation for me to start working, for us to start working on it.
Mm-hmm.
I mean, that it's in progress. It's just that she's doing a lot of the automation stuff and kind of bringing it more closely in alignment with current build process.
Right. The workflow side of things.
Yeah.
Yeah, I'm excited to jump into that.
Yeah.
All right, Deshipu?
Can you hear me?
Yes, I can.
Super. Okay, so I'd like to give a hug to TG Techie for his Metron for Sandy 51 board, which is great, and to Scott for developing the arcade feather wing and for getting Celeste to work on it already, at least a prototype of it.
Yeah.
And I think that's all I remember.
Okay. Thank you. All right, Jerry.
Yeah, just thank or hug to Dan for fixing that ESP8266 stuff. That was a little puzzling for a while. And also to Deshipu Radomir, thank you for convincing me or pushing me to try out the gamepad. That's really cool. And I don't know how I missed it, but I'll be using it a lot in the future. I was just trying to do some simple buttons, and he said, well, use the gamepad. And then I thought, oh, Yeah. Very nice.
Awesome. Okay, Katney.
Yeah, I want to give a hug, I think, again, to Summersoft and Carter for both helping me with the guide I'm working on. Both of them took the time to put in some extra work so that I could get screenshots of the entire process of doing pull requests and so on GitHub, which takes a long time when you have to stop every single step of the way and do screenshots. So thank you very much for that. And thank you to Roy for helping me get a better idea of updating the branch when it's behind and rebasing and all of that. I may be adding that in and definitely going to need help with that. And Roy started explaining that this weekend. So
awesome.
That's going to be super helpful there. So thank you.
That guide's going to be so good. It's going to be awesome. Very excited.
I'm looking forward to it.
Yeah. Yeah, I think a lot of us are. Okay, Mike's lurking, so we'll go on to Nis.
Hi, I'm trying out a new mic today. I just have a little hug report. Can you hear me?
Yep.
Yeah, for Phil at Adafruit, because he came in on Sunday and we talked a little bit about content discovery for the stuff that Adafruit does, and that was a pretty interesting conversation.
Awesome. Yeah, I saw that. It looked really cool.
And that's it for me. Thank you.
Thank you. All right, Noe.
Hey folks, group hug to everybody.
Group hug. Thank you, thank you. Roy.
Group hug this week, and also hug goes out to you for the great feedback on the PR, which is sort of helping me steer the direction I'm moving the pixel buff stuff. And I've got a bunch more refactoring to do thanks to the feedback.
I didn't mean to create more work, but I think it's really awesome work, and I'm glad you're taking that on. I think it'll make, it's gonna make it all really, really good. So, thank you for doing that.
You're welcome.
All right, STW, aka Scott. Maybe group hug plus everyone who wrote the documentation, forum answers, etc. that I consulted while working on MicroFlash. If you have a link to MicroFlash, you should put it in the comments too, so people can see it. And last but not least, Summersoft. Says, hug reports to Jerry N. and Deshipu for the support they've engaged in on Discord and GitHub. I may have missed mentions for others. I blame Monday Brain. I know what you mean. Fighting it right now. Arturo182 for the NRF cleanup, and excited to see that port getting attention. Group hug beyond that. Okay. I will copy that in. And Scott just posted a link to, so the link will be in the notes. For MicroFlash. And that is hug reports. Thank you everybody for all those thank yous. Moving on to status updates. Sorry, I'm distracted by conversations in the Discord. Status updates are a chance for you to talk about the work that you've been doing and the work that you plan on going forward. It's really good to get all of us aware of what everyone else is doing, and also have a chance to say some tips and tricks about, like, oh, you might want to try this or that, but also a chance to say, like, let's have a longer discussion about that. And I just remembered I forgot to talk about that. So at the end, after this section, we'll have a kind of discussion / in the weed section, which is all of the odds and ends that we want to talk about. So if you have something that you'd like to discuss more broadly, then mention it in your status update, and we'll circle back to that. I can write it in the notes and do that. So okay, I'll start with my status update. I made good progress on the Celeste port to the new handheld prototype. I posted a video on the Discord. I haven't shared the code yet because the licensing on the code is a bit unclear. Pico 8 is very is structured to be very share friendly, because the resources and the code are not obfuscated. Really, they're just in a text file, which I am currently able to load on the handheld using CircuitPython, which is really cool. But there's no clear license designation on that currently. So I've actually reached out to the Celeste folks, and hopefully they will get back to me. I may take some time to get that running in the Game Boy, but I think I'm actually going to jump onto the NRF stuff just for a bit so that I can get more oriented to the workflow and how that works in the upcoming week. We want to do some workflow polish on that, and I want to get a better idea of where the port is at as well. So I'll probably take a bit of a break from the gaming stuff and do that. Still figuring out the API side on the gaming stuff too. So letting that stew in my brain is a good thing. Reading my notes, I also wanted to do a little bit more of the memory heap profiling stuff. I was having an issue with the Celeste stuff where my heap was 150K and I was still hitting memory allocation errors. I was trying to allocate 16K, which is still a lot, but the GC mem free said I had like 80K free. So there's some fragmentation that's still happening, and so I've set up a separate computer so that I can kind of just like hook it up and let it run, and then do some more of those diagrams about how the heap is working in the current version. So that should be interesting, and we should see some more memory optimization coming out of that as well, I think. And I've also been thinking a little bit about CPU profiling too, because trying to hit a 60 frames per second speed means that you have to be aware of what is costly in terms of CPU cycles and stuff. So that'll be super interesting. Kind of going forwards, my stuff is a mix between gaming and Bluetooth stuff. So that's it for me. Let's circle back and start with Andon. I know that was a bit rambly, but Andon says, status update, things moved, many things, including my PC. Plus side, I have a setup I can use it for show and tell. I also have some EL wire in the mail. I will be doing fun projects. Pick is new desktop computer setup. So if you're just listening, you should go watch the video recording. There's a picture of a 2x3 monitor grid that Andon has set up to be able to do all the things all at once on the new desktop setup. So it looks very cool. Okay, Carter.
Yeah, I did a few PRs for that same HT16K33 repo, and they were able to close out at least one of the issues. Mm-hmm. But then I created yet another issue for another feature, and we'll continue to work on that.
Awesome. Thank you for doing that. That's the display stuff is as you know, something that is needing some more attention, which is really nice. All right, go ahead, Dan.
So aside from fixing the bugs I mentioned that Jerry found, I wrote a wrapper library for the Cricut. So it's really easy to control the pins on the Cricut without having to worry about creating an I2C object or a Seesaw object. And that's in Adafruit CircuitPython Cricut. Mm-hmm. And you can try it out if you want. It requires, I have some UF2s that have this frozen in, but I have to wait for a couple of PRs before we put it into the main line. So if anyone is interested in that, I can give you something to test, and I'll paste the link to the repo here in just a minute. Here we go. Okay.
Yep, got it.
And I'm starting to work on NRF stuff too, but just getting started.
Yeah. Cool. I'm excited to do NRF stuff. All right, Deshipu.
Okay, I couldn't do as much coding as I wanted. So instead, I played a little bit with hardware again, and I have another CircuitPython based project.
With what?
So this is a reiteration of those robots I've been making some 2 years ago.
Oh, right.
It's like more compact and easier to assemble, and I want to eventually sell a kit on Tindy with that. So I'm trying to make it as simple to assemble as possible.
Cool. Thank you for the link. I want to go back and look at it after the meeting's over, because that's all really neat. All right, Jerry.
Yeah, most of the week spent just playing with it, finishing up or not finishing up, but just working on a bunch of not CircuitPython projects, just trying to catch up on things. And now I've been spending a bunch of time trying to get some a Raspberry Pi to communicate with a LoRa radio to the CircuitPython, but really struggling on the Raspberry Pi side right now. So that's distracting me. But I did get a one of the SDK boards for the NRF52, so I'm looking forward to that as well. I'll be, trying to test it and play with it as it comes along.
So. For the Raspberry Pi stuff, Lamore is working on creating a library so that all of the CircuitPython libraries are usable on the Raspberry Pi.
Oh wow!
And yeah, I know
the library. Oh, go ahead.
I was gonna say I know you've used the LoRa stuff on CircuitPython, so that would be an interesting approach to take it.
Yeah, and somebody's actually put out a driver. It looks very close to what's on to the Raspberry Pi, and it looks fine. My problem is the SPI interface. It's just not working properly. When I try and run that driver, the SPI works fine if I talk to some other SPI device, but I'm just getting flat lines on some of the lines. So something's not right.
Weird.
I'm sure when I find it, I'll be kicking myself. But
yeah, that's how it goes, isn't it?
Right.
Cool. Thanks, Jerry.
Yep.
All right, Kenny. All right. So working on the GitHub Git workflow guide, I had to end up photoshopping like a third of my screenshots because they looked really big on my laptop screen and easy to read, but my laptop screen is super high resolution. So I put it on a normal screen, and in the Learn guide itself, they were basically impossible to read. So that was a majority of what I've been doing over the last couple days, is handling all that. But I think the biggest parts of the guide are done. There's still 2 sections that I'm going to end up seeking help with, or 1 section I'm going to end up seeking help with, and another one is still kind of beefy, but the last few are simpler than the rest, I think. So that should go pretty quick. I think the next 2-3 days maximum, and I'll be done with that. The next things I'm going to be working on is updating the ITSE M4 guide to include the essential stuff, and actually going through the essentials guide with the ITSE M4 and making sure everything runs. That's 100% likely to work, but you never know. You always find bugs.
Yep.
And then I also want to try this week to finish up the code of conduct and get that finished up and done. I've got the feedback that we got, and it's good. So I'll run through that and still probably have you obviously review the changes I make, since some of them are actual content changes.
Right.
So we'll go through the same review process, you and I, and it should be good to go.
Yeah, I think it's super close.
So I think that's where I'm at. That probably sums up about the rest of the week, unless magically things go way faster, in which case I do have, a laundry list of other things to do, but that is probably likely to be my week.
Yeah. Knowing how epic this GitHub guide likely will be, it makes total sense.
It's massive. Limor had initially talked about putting it in the current Git guide.
Right.
And just it's like 9 pages by itself, so we can mirror it in. That would be fine. But it was definitely not gonna function just as a slightly extended part of another guide. It's definitely standalone. So
awesome. Well, good work. I'm excited to see it.
Thanks. I'm excited to get it released.
Totally. Okay. Nis.
Let's see here. I got my splashdown. Did a lot of experimenting with Git and GitHub this week, and found a means to synchronize the branch to the master. I'd put a link there.
Oh, good.
That helped a lot because I really couldn't figure out. I was always one commit off when I did a pull request through the web interface, and I still don't understand why that's the case. But there's a very easy fix. So I'm starting to collect little recipes, and that helps a lot.
Awesome.
Dan told me about Gitka, I guess you could call it, pronounce that.
Oh yeah,
Gitka.
Yep.
Because it helps you visualize your diffs, which is what I need to know in the commits. To see what you added and what code you removed. And I looked at diode clamping for port pin protection, and starting to separate what's placebo from what's actually useful.
Right.
So that's it for me. How's this mic sound?
It sounds about the same as the previous one to me.
Oh well, this is a CB microphone or ham radio microphone.
Yeah. Well, I can hear you loud and clear, which is fine.
Okay, great. Thanks.
Yeah, and I'll be excited to hear your feedback on the Git guide. Since you've been in the thick of it as well.
Oh, definitely. I'm still in the learning phase, so I'm a good guinea pig for this.
Yeah, it's got a pretty wicked learning curve, so a lot of us are still there.
I'm getting it though. It's. I encourage anyone that hasn't tried it to roll up their sleeves because it's very rewarding.
Yeah, that's how I feel too. The learning curve is kind of painful, but once you're there, you're like, okay, I understand why people like it.
Yeah,
it just takes time to get there.
It helps you, organize. That's its whole point. And then you can eventually interact with other people.
Yep. Totally.
All right.
Thanks. All right. Noe.
Hey. All right. Give me a second to paste this. So you can just paste that into the notes.
Okay.
So I'm working through the learning guide for this week's project. It's that touch tone synthesizer for the CircuitPython Express.
Ooh.
Kind of fun. And then we updated the CAD model for the CircuitPython Express because we had an older version. It was like Rev D or Rev C. So the update has the the IR LEDs and just about every sensor. So if anyone's working on a case that needs to be really precise, the component should be there and like the precise placement.
Cool.
And the last thing we did was I updated some of those SVG graphics. Well, yeah, those SVG files for our Circuit Playground characters, specifically for iron-on vinyl. So I've been making some T-shirts, and I put those on GitHub as well. So if anybody wants to play with those, they're up there.
Cool.
We have some more cardboard-related projects. Blow up some fireworks with Circuit Playground.
Ooh. That sounds celebratory.
Because we got this button. It's made out of cardboard. And maybe we can ignite some match heads or something. I don't know. We'll see. We'll see what we can do with it. But that's what we got working on.
Awesome. And if you ever have a chance, since you like doing the synth stuff, it'd be interesting for you to take a peek at like Pico 8 and take a look at their synth stuff that they've got there. I don't know if you've ever done much chiptune stuff, but love to get your feedback on that.
Okay.
Cool. All right. Roy.
So let's see if the video post works as well. So
Yeah,
there we go.
Should I play it for the recording?
Sure, if you want. So this week I got the .star support working in the pixel buff stuff, which required a bit of changes because .stars are RGB and a brightness bit, whereas NeoPixels are RGB or RGBW.
Right.
But both are now working. I'm able to drive with about 4 times better performance, a 144 pixel strip of .stars, and the 72 pixel Featherwing works really well as well. It's obviously not as fast as if everything was in C, but it's getting usable now to do some animations and stuff. So frame rates are no longer really slow. The color wheel sample, for example, on the 144 pixel or .star strip took about 2 minutes to do the full cycle before, and now it takes, well, 4 times less time.
That's super cool.
I'm pretty sure there's a lot of optimizations to be done to make it even faster, but I think the goal now is make it work, make it mergeable for, say, 3.1 or something, and then we can start to link other stuff in to make them pretty and start to do some of the stuff that's done for, what's it called, FastLED, I guess? So try to do some of those kind of clever things so that people can have really fast, awesome, pretty stuff.
Yeah, there's... Philby did some work with a library he called Fancy LED.
Yeah, I saw that.
It was renamed from Fast to Fancy because it was not fast.
I actually wanted to benchmark to see how much faster Fancy LED becomes with these changes.
Yeah, that would be super cool to see. And
it'd be good to, if we have a bit of time at the end, to chat more about how you think we should restructure the CircuitPython, NeoPixel, and .star libraries to have sort of that shared library you talked about in the merge request.
Yep. Adding that to the discussion notes so I don't forget. Cool, thanks, Roy. All right, STW, Scott.
Okay, so I pretty much finished up what I'm doing with MicroFlash here. I'll post here. I made a test release just in case anybody wanted to try it out, other than pulling from the repo.
Right.
So I tried to be as comprehensive as possible in not leaving stuff for Nicholas to have to do. So it was interesting getting my fingers in a lot of pies there and changing a lot of different things and trying to figure out stuff I'd never done before, which is good.
Right.
So I got it all. It's all working well, I think. Other than if Nicholas wants me to update anything or change anything, I think it's pretty much done. But the only other thing I think I would do on it is that once I learn some more about GUI programming, I might make a GUI wrapper for it. But that's pretty much done. Yeah, I don't know how long it's going to take until Nicholas gets a chance to do anything with it.
Okay.
But yeah, it works anyway.
That's from you?
What do you mean?
Which Nick are you talking about? Ntol?
Yeah.
Cool.
And then over the weekend, I started looking at the CircuitPython plugin, Thawny. Yeah, it looks interesting. I just started looking at it, and I updated I have a Feather. So I updated to it is libraries, but I think this. I started messing with some code a while ago and didn't get too far and kind of put it on the back burner. And so things in the library evidently have changed, so it's not working right now. But I'll mess with that some more.
Okay. Awesome, thank you. And Summersoft says, frequency in module, I abandoned using count for the time being. npob's new small int was giving me too much grief post math. Working on accuracy, as I believe it's largely tied to the external interrupt latency. Currently catching up on all the math I never did / paid attention to. Hug report to Khan Academy? ? Smiley face. Debating on picking up an NRF 52840 dev board. Who am I kidding? It's not a debate. Little Leslie amp. Spent some time on this over the weekend. Salvaged a surround satellite speaker, which include a 1-inch tweeter and a 3-inch mid driver and crossover. The Cricket's amp drove them very well. Started a SketchUp for the cabinet and brainstorming on the rotating bits. Fighting feature creep is tough. Yes, it's very tough. Yeah, feel free to take a break from Frequency In. I know when I get hung up on stuff, sometimes going off and doing something else means that you come back to the older project with a lot more clarity. That's kind of where I'm at on the gaming stuff. I'm like, oh, I'll just take a break and do the NRF stuff and then come back and really have some more things decided for myself, I think, for the gaming stuff. So all super exciting. So thank you all. That's the status updates from everybody. This one last section is the discussion / in the weeds section. I didn't have anything in specific, so we can jump straight to Roy's discussion of NeoPixel and DotStar. Roy, do you want to just lay it out for folks who haven't followed along?
Sure. So one of the things that I've done as part of this is I started to simplify, I'm going to back up a little bit. I've created this pixel buff class that is in CircuitPython. It is accelerated code to deal with the brightness adjustments, since NeoPixels and DotStars are stupidly bright. And so almost everybody operates with brightness less than 1. And especially beginners, they don't understand the performance implications of doing so, because one of the things that happens in the code is every single time you do a update, you end up copying a buffer and doing math on every pixel to adjust brightness. And that math is pretty quick to be done if it's done in C, but it's really slow to do it if you're doing it every time you do a write to the pixel or to send your pixels out to the strip.
Right.
So Pixel Buff does that calculation, and it can operate either with or without a second buffer. And if you have 2 buffers, it keeps one that has the unadjusted values before brightness is applied, and another buffer that contains the brightness adjusted values after you, or as it goes. It computes them as you go or whenever you set brightness. And it does this nice and quick because it's in C. It also does the work to deal with the RGB order shuffling, which is quite slow again in Python and much faster in C, and I'm pretty sure we can accelerate it further on the C side of things. But this means we have to change both the DotStar and NeoPixel libraries to use Pixel Buff to get that speed gain.
Yep.
And Scott had suggested that we make it sort of a pixel buff that's in C as well, so that we can import from that when there's no internal support for, or no built-in pixel buff, such as on memory-constrained devices.
Right.
And as part of that refactoring, there's a bunch of shared code between NeoPixel and DotStar and possibly other ones. And possibility here is we might need a new class, yet another extension, or I'm not really quite sure how we want to approach this without adding more bloat to the code base and complexity and having to freeze more things in and such. So that's where I wanted the discussion to start, to help steer where I go next.
Yeah. Go ahead, Dan.
I would really like to see, I don't know if it's too much bloat, but I would really like to see like just an RGB LED superclass that does all the common stuff, including maybe calling Pixel Buff. I don't know if you can do that or not. And then have subclasses for each of the different kinds of RGB LEDs. For instance, I also, for the Cricket, the Seesaw supplies a NeoPixel support, and there's some duplicate code in there that was copied from the NeoPixel library. So it just kind of seems ridiculous that there were so many places where fill is implemented or something like that. But I don't know. I haven't looked at pixel buff enough to know whether it could be hoisted up to an abstract superclass or not. So what do you think about that, Roy? I mean,
I think that's the right approach.
Okay.
So I was actually looking at the resulting dot star and NeoPixel classes after using pixel buff, and like it looked like 80 or maybe even 90% of the code is identical now.
Right.
Because they're all the calculation logic for dealing with RGB and byte order shuffling and brightness calculation is now very embedded in pixel buff. So it shouldn't be too hard to take the pixel buff code, make a Python version, then also move a bunch of the common constants. Like one thing that's bothering me a little bit right now that I haven't addressed properly is that the byte order constants are actually numbers, and they're not classes and such. So they don't work real well with all the other classes, and they even change some of the semantics if you happen to, like, they're not subclasses of whatever class it is that they are. Right now, I think right now they may just be tuples of the order, but but I like the way, for example, in board, that those constants are just classes for the pins.
Right.
And we could probably have same kind of classes. Maybe they should be part of CircuitPython as part of pixel buff. And then we can depend on that during a bit of a common refactor. So I guess we would end up with 3 different libraries, at least to start, and then 4 once we add the, what are the really super bright LEDs called?
The Pixies?
Yeah, the Pixies.
The like 3-watt ones?
Yeah, so Pixies would also probably be another class that depends on this RGB LED stuff. And
yeah.
I think that there's some code here as well for dealing with these byte order shufflings that could possibly be reused elsewhere. Because anywhere you're dealing with displaying pixels, that's going to come in handy from getting a tuple into a pixel.
Yeah, for the LCDs, they're particularly weird though. I've been doing a little bit of that with the gaming stuff, and they do 565 encoding, so you're packing like a 3 tuple into 2 bytes. So it is pretty weird, but a lot of what I'm doing and the way that I'm leaning is that it's all palette based. So you say like you have a sprite where each pixel is like 4 bits or something, and then that just maps into some palette that you've already done those adjustments for. So you only have to do them once up front, which makes it less critical.
Reminds me of video in the 90s, early 90s.
I don't think that's a bad comparison from what I understand.
I think one question is whether if you add this abstract superclass, whether the current import structure is going to work right or not, whether you can make it upward compatible. And so if it's really tortuous to make it upward compatible, maybe we need to have a NeoPixel 2 and a DotStar 2 or whatever sort of next gen versions of those libraries. That's a big break, but I mean, I would say is like don't tear your hair out trying to make it necessarily completely backward compatible if it makes it very difficult to do or reduces the performance. It prevents you from doing the kind of performance improvement that you want to do, because just like there's fast LED and fancy LED libraries, maybe there should be a restructured RGB LED library with the appropriate, like that could be a new library, the RGB LED library, and then you could import the appropriate implementations, and so they could live frozen, or they wouldn't be they'd only be imported into RAM or imported from Flash as necessary, but everything would be packaged up together in a single library. That you can think about that. Okay, that's sort of like it's like a naming.
Mm-hmm.
It might be a big break, but maybe that's kind of the right way to do it. So.
Yeah, because the current NeoPixel libraries and .star ones will continue to function as is.
Yeah, yeah.
And the calling convention's not changed. Being very careful to make sure behavior is identical with and without the acceleration.
Right.
One thing I did do at Scott's suggestion, or maybe it was yours, I can't remember, is to try doing a specific branch that's frozen of the .star and or sorry, of the NeoPixel library that was minimalist. So it might be a little confusing to have the frozen versions be different than the most recent versions, but we could sort of head down that path during a transition period where if you import or if you download and add NeoPixel or .star libraries to your code from the repo, you're going to have code that's conditional. But if you based on whether or not it can import PixelBuff, but if you grab it from a frozen version, it will depend on your board's ability to have the PixelBuff hard-coded in or not, and you'll get a slightly faster version that doesn't have any conditionals.
Right.
Well, the conditionals in the main line, or are they just conditionals on the import? Like we often we have a number of library tricks where we try to import something, and if the import fails, we put the import in a try except, and then we just do something else if it fails.
Yeah, in this case, I didn't import it. Oh, you know what? That might actually not be a problem if PixelBuff is baked in as a frozen, depending on how big it is. But I do have a try except in there during the import, but then I just check to see if the import had succeeded by checking if the value or the constant is defined, and if it's not, skipping over the acceleration code and running the regular code. So
yeah, the way that I had pictured it is like right now you had the unaccelerated code still in like NeoPixel, but Python has long had this idea of like the pickle module, which like they had a C version and they have a Python version. And so I was thinking we could follow the same model where rather than having that backup Python logic in the NeoPixel module, you actually just have a Python version of PixelBuff that you can grab if you don't have the C one.
Yeah, I'd followed that quite closely, and it's just it's the transitionary period where that's why maybe we should go with a version 2 that's fully accelerated, is based on the RGB class and such.
I'm totally fine with if we just release NeoPixel 2 and then we say like this requires Python 3.1 or CircuitPython 3.1 or something. Like we could do that.
Yeah, and I don't think it is NeoPixel 2. I think it's actually RGB LED with multiple subclasses all in one library.
Yeah, maybe that's actually the right thing here is to switch away from these dedicated purpose libraries and have a single RGB LED class that then has subclasses as needed. The documentation will become clearer as well.
We've talked about this multiple times, and I agree, in the sense that every time we have updated anything that is designed for, like right now, there's a community written library for the .star Featherwing, very specifically for that. And one of the things that when we were writing it into the Featherwing library list that Scott had mentioned was we should try and make this more abstract so it can be used for more than just this library. And I think that's definitely the right direction to go. I think that's where we've been talking about heading for a while, and just we haven't picked that stuff up again since.
Yeah.
It's fine. It's fine with me.
Do you happen to remember if that .star one was to make it so that it was an XY addressable coordinate space?
Yes.
Okay.
So I wonder if we don't want eventually to merge that with the frame buffer module at some point.
Right.
Yeah, that was sort of the direction I was asking earlier in the conversation. Is this sort of a frame buffer or not?
Well, yeah, I mean, it can. I think FrameBuff might use it, but FrameBuff assumes a 2D I mean, FrameBuff has all kinds of like draw lines and rectangles and stuff, and that doesn't make a lot of sense in many cases when you're doing like NeoPixel strips.
Right, but it does make sense for the Featherwing dot star because it's 6 by 12.
Right.
Which is still pretty low resolution, but I can definitely see people wanting to draw circles.
Well, it makes sense. I mean, it makes sense for the NeoPixel panels too. I mean, we just have a new product that came out last week. That's a panel for the flexible panel. So, but I see it as using that, whether it's part of that. I mean, if you look, also FrameBuff is kind of Lemur wants to rewrite FrameBuff, and make it more like the Adafruit GFX lib, which sort of lets you plug in implementations of PixelWrite underneath. And so I wouldn't take the current MicroPython-based FrameBuff as the direction we want to stick with now necessarily.
And the problem with FrameBuffs and NeoPixels and dot stars is getting the encoding right to transmit. Because you're not directly bit blitting.
Yeah.
We would have the FrameBuff library for representation of bitmaps in the memory, basically, and then have individual libraries for sending them to different kinds of hardware.
Yeah, that's the model I'm going towards too. In my mind.
And I think we'll have the performance for that in M4 land, but I don't know if we do have the memory and performance for that in M0 land.
Yeah, I think it's good to think about the FrameBuff stuff, but don't let that slow you down on the RGB LED stuff. Like,
it's not like we can't refactor later anyway.
Yes, and I totally have fallen into that trap myself of like, I want to change the world, therefore I don't get anything changed. I think we're kind of dancing around and we're getting closer to figuring out what we want, but I think doing the RGB LED stuff to start with is a really good place to start. The thoughts I've had on the FrameBuff stuff kind of go in two varieties of like, I want some like standard in-memory format that we can use, and then we can have like separate classes that know how to transmit that to particular devices, but also like separate classes that know how to manipulate it. So rather than having one thing that does all of the shapes for everything or all of the text for everything, we have actually just different modules that can mutate kind of some standard structure using C to accelerate it. But at the same time, a lot of this game stuff that I've been doing doesn't even store bits in memory, really. Like, instead, it's got like it's all the stuff, the awesome stuff that Radomir did, where you're just keeping track of like how your bitmap is structured. So like there's a grid of sprites, and you have the sprite memory separately, and it's indirected. And then like the only time you're actually putting all those bits together is right before you transmit them.
But you still need to keep the graphics in memory somewhere, and it would be nice to have a standard data type.
Yeah, for like the sprite storage.
Yeah, exactly.
Yeah. Yeah.
So one thing I want to add to MicroPython now, and I already have like 10 tabs open for that. Is GIF decoder, so that we can actually open GIFs and have the resulting picture data, and even animated GIFs. That would be also super great with things like NeoPixels, even if they are so low resolution and so on. And the code actually is not that complex, and it's quite short. So perfectly, that would also return your FrameBuff or some standard way, so that you can plug it into any library.
Right.
So that accepts graphics.
Yeah, I think we're going the right way. But yeah, let's just, Roy, I think you're going the right direction. I would say keep going that direction, and we'll figure out these bigger, broader questions as we experiment and see how we can use them. Like, the animated GIF stuff that Radomir is talking about will inform what we want, and so I think let's just keep experimenting, and we'll settle on something as we do that.
Sounds good.
We can always move forward. We can work forwards.
And we can also throw away work and start over.
Yep.
That's the beauty of software.
Yeah, just got to get the hardware right.
Exactly.
Cool. Anybody else have discussion topics? It is noon on the nose here in the Pacific Northwest. All right, I'll wrap us up. Let me think about what I usually say. Thank you, everybody, for joining the meeting. As always, it happens every Monday at 11 a.m. Pacific, 2 p.m. Eastern on our Discord channel. To join the Discord, you do adafru.it/Discord. That'll drop you into the welcome channel, and then you can join the CircuitPython channel to text chat with all of us, which is cool. And we'd be happy to see you there. If we do end up moving the meeting times, we'll post it to that text channel, so take a look at that. This meeting, what has been recorded, I record both the audio and the text chat from Discord, so check our youtube.com/Adafruit to see the recording if you missed it. Of course, if you're hearing this, you didn't miss it. But you can also find past episodes that way as well. And yeah, everybody's welcome, and we'll talk to you all next week.
Thanks, everyone.
Later.